Okay, so let's take a look at problem number 86 here. The problem asks me to expand 2x squared plus y squared to the 12th. Now, in the past, I've done this using this Pascal's triangle thing. If you go back and look at some of the videos in the past, you'll see that I've done something like this to be able to get the coefficients for the problems, right? There's a little bit of an easier way to get this, especially when you're dealing with bigger numbers. So let's see if I can get this 15 without having to do a whole lot of work, right? So what I want to note is I'm in the, so if I count this as the 0, 1, 2, 3, 4, 5, 6th expansion, right? So I'm in the 6th expansion. And just like I started with counting the 0 here, I'm going to count this the same way. This is the 0, first, second power, because remember, like, this is the coefficient. It's going to be like 1a to the 6th b to the 0, right? And then plus 6a to the 5th b to the 1st. So these numbers actually go with the coefficient, the second power there. So I want to always start counting with 0. So I'm in the 0th row and I'm in the second place. So 0 and 2. And I want an operator that's going to hook up with those numbers together and give me a 15. And the operator that works here is actually what we call the combination operator, or the choose operator. So this has something to do with permutations and combinations. And fortunately for us, under math probability on your calculator, option number 3 is that NCR option. So if I put in here, oh, sorry, it's not row 0, this is row 6, right? So it's row 6, space 2, right? So let's do this. Let's go back to the main screen. Go 6, math, choose 2. There's my 15. So which means that, like, if this one's in the 3rd spot, right, then I should do 6 math choose. Oops, that's not choose. No, that's definitely not the choose. Let's get that out of there. 6 math, let's delete that. There we go. Math choose 3, and we should expect to get a 20 there, right? So that's the next one over, and boom, there's the 20. So we have something that's working here. All right, so let's go and think about this problem. I am expanding this to the 12th, so I'm in the 12th row. So all of my coefficients are going to be 12 choose something, right? And I want to know the first 4 terms. So I need 12 sub 0, 12 choose 1, 12 choose 2, and 12 choose 3. So let's figure out what those are. So let's go 12 math choose, why did I do that again? I don't know. Math probability choose 0 should be 1, right? Because all of these are 1s, right? So that's the 1. We should expect that to be 12. So let's try that again. 12 math choose 1 is 12. Okay. So how about 12 math choose 2? 66. Okay, so it jumps up there. So this one is 66. And then we go 12 math choose 3, right? So this one's going to be even bigger, 220. Okay, so like you could work out the whole Pascal expansion for this, but that's just like seems like a lot of work. All right, so I'm going to write this back here. Remember, we're trying to expand 2x squared plus y squared to the 12th, and we want the first 4 terms. All right, so I'm going to scroll down a little bit here and get myself some more room to work. All right, so remember, we're going to take that coefficient 1, and then we're going to take the 2x squared to the 12th times y squared to the 0 plus 12 times 2x squared to the 11th times y squared to the 1st plus 66 times 2x squared to the 10th y squared to the 2nd, and then finally 220 times 2x squared to the 12, 11, 10, 9th y squared to the 3rd. Okay, so let's see. I need to know what 2 to the 12th is here. So 2 to the 12th is like 4096, and then we're going to multiply that by 1, so that's just going to be 4096 x to the 24th. 2 times 12 is 24. Y to the 0 is just 1, so that's the first term. Okay, so I need 2 to the 11th. 2 to the 11th is 2048, but then we're going to multiply that by the coefficient 12. So that's going to give me 24,576 x to the 22nd y squared plus, all right, so I need 2 to the 10th, 1024, and then we're going to multiply that by 66. So that's going to give me 67,584 x to the 20th, y to the 4th, and then we need 2 to the 9th. It's 512, and then we're going to multiply that by 220. It's going to give me a big number. All right, so that's going to give me 112,640 x to the 18th, y to the 6th, and it keeps going, but that's the first 1, 2, 3, 4 terms of the expanded polynomial. So that's it. That is problem number 86, and we got